This week on the BackTable podcast.
And so we needed something that could make care consistent. And we saw that in our FDA study. We were able, even in some of the best stroke centers around the country where we did the study, we were able to not only reduce the time from scan to alert of the specialist by around an hour, but most importantly, we reduced the variation from well over 120 minutes down to 7 minutes of variation in when this doctor was alerted.
Wow.
To me, that's the major issue that in healthcare that technology can solve. Right? When things align, that patient is treated, with the standard that we want them to be treated. But on average, that's not the case. There's so much variation in healthcare, and AI solves the standard deviation problem.
Hey everyone, and welcome to the BackTable podcast, your source for all things endovascular and otherwise minimally invasive. You can find all previous episodes of our podcast on iTunes, Spotify, and of course on BackTable.com. This is Bryan Hartley as your host this week. I'm a radiologist living in Silicon Valley and co-founder of an early stage device company in the pulmonary space. Before we dive into our topic today, just want to say a quick word from our sponsor, RadPad. RadPad radiation protection products, developed by physicians for physicians and clinically proven to protect during cine and digital subtraction angiography. Don't bet your health on anything less. Trust RadPad protection for all your interventions. See radpad.com for more information and contact info@radpad.com to learn more about radiation safety CME credits for you and your team. We're very excited to have our special guest this week, Dr. Chris Mansi. Great to have you, Chris.
Thanks very much for having me.
Oh, of course. This is our next installment in the BackTable Innovation Series, where you will hear stories from physician innovators who are helping to shape the interventional field through health tech. Dr. Mansi is a neurosurgeon and CEO of Viz.AI, a startup in the AI space that is on fire right now. So Viz.AI is using AI, artificial intelligence, to improve patient outcomes in the stroke space, reducing time to treatment and improving access to care. In today's show, we're going to hear about Chris's path through neurosurgery and what led him to Stanford Business School and ultimately to start a high-impact AI company. Again, Chris, thanks so much for coming on the show.
Thank you very much.
All right. So starting off, why don't you tell us a little bit about yourself? What do you do? Where are you from? Those types of things. Training background.
Absolutely. So you can probably tell from my accent that I'm British. So I trained in the UK as a neurosurgeon. I was at medical school at Cambridge and UCL, followed by residency in Queen Square and King's in London. And I was lucky enough to be able to take a sabbatical to spend some time at Stanford in 2014, where I did the biodesign program and an MBA combined. And that really, changed my career a little bit. Prior to Stanford, I certainly had an entrepreneurial mindset. I started a couple of companies in the medical education space. But being out here and seeing the amazing technology, the amazing entrepreneurs, the amazing companies that are built out here really inspired me to take what I was doing to the next level. And in 2016, I founded Viz.AI, which is a medical AI company focused on improving access to care and improving the speed and efficiency of care, trying to take the average standard of care up towards the very best so you get the same care no matter which hospital you show up to, no matter what time of day of week. Really trying to maximize the effectiveness of the expertise that we have in medicine so that if a patient needs a thrombectomy, for example, they will be connected via our system to the right neurointerventionalist to get the treatment that they might need.
Awesome. It sounds like you have done a lot of stuff since your training. So starting back there, so you finished your neurosurgery training and you said you founded a couple of startups previously in the educational space. Can you maybe walk us through that? What motivated you to want to do that? Were you in your training or were you already in attending by that point?
Yeah, it was my training, and I wanted to really make learning accessible. This was the early days of e-learning, the likes of Coursera, etc. And I wanted to develop an educational program for surgeons that was easy to use while dealing with the demands of a surgical residency. And so the company EduSurge essentially puts online modules for what we call the membership of the Royal College of Surgeons, which is equivalent, I think, to the either the step threes. You take the exam when you're maybe 2-3 years post med school, and you're looking to specialize because the system's slightly different out in the UK. And we essentially built a bunch of content, built a platform for others to put content online, and created modules for this particular exam, which is a Viva style exam. And for me, what was interesting about it was the first time where I set something up from scratch, my first entrepreneurial experience, and I had to just learn a lot. I had to learn how to empathize with the user and put stuff out there. What I now know is marketing, right? I had to learn how to put a website together. I had to learn how to build a team. And so that early experience was great, and it really set me up for the next stage of my entrepreneurial journey at Viz.
That's great. And you were so you practiced for 5 years, and was EduSurge still going on? Were you running it, or what happened with EduSurge?
Yeah, it's still being run by a small team in London.
Great.
Yeah.
That's great. It sounds like that was kind of where your entrepreneurial fire was started, so to speak.
Absolutely. Yeah. I think just I speak to a lot of clinician entrepreneurs like yourself, and I think all of us have got a very similar story where you just go, hey, I'm going to try something, and you don't really know what you're doing, but you just give it a go. You create something from nothing, and you learn along the way, and you continue iterating till it works.
Yeah, that's exactly what interviewed previous Rusty Hoffman, who's an IR at Stanford. He said the same thing. He says you really just have to get started. You course correct later, but just getting started is probably the most important step.
Correct. I agree with that.
That's great. Did you do any endovascular work during your practice?
I didn't, no.
Okay. So tell me, at what point in your career did you decide, I'm going to take a sabbatical? I love this entrepreneur stuff, but I want to formalize my training in business. And, what prompted the move to Stanford? Obviously, it's one of the best business schools around.
Yeah, so I have to admit, back then, I probably didn't even know what an MBA was. I was very focused on my clinical work. But I started this company and was learning a lot. And a friend of mine who was helping me said, hey, you seem to like this stuff. You should consider doing an MBA. And I sort of looked at what it was. I was reading a lot of the material coming out of Silicon Valley, like some of the blogs coming out of the Y Combinator program, a bunch of the books like The Lean Startup, Crossing the Chasm, and I sort of realized this stuff did really interest me, and so I was lucky enough to be granted a sabbatical and came out to Stanford for 2 years with the plan to go back.
Of course.
And Stanford being Stanford, I was in a business school class and was lucky to be taught by Eric Schmidt, who was the CEO and chairman of Google at the time. And I pitched the idea for Viz in the class's business school, business plan competition. And he liked it enough that he ended up seed funding the company. Wow. And I think back then I didn't really understand how venture capital works, but I thought having a few $1 million to try and make this happen was very exciting.
Right.
I had to have this conversation with my boss back home saying, hey, I might be out here for a bit longer.
Yikes. Yeah.
Can you extend the sabbatical? And they said yes, and actually ended up turning into me doing this full time and leaving clinical practice.
Wow, quite the jump, and I want to get into that in just a little bit. But back to the MBA, because it sounds like you had a fantastic experience there. Eric Schmidt teaching you, and then funding. So, what were kind of some of your takeaways from getting an MBA? And maybe you can walk us through some of any experiences that you had that were maybe transformational. I know there are probably several clinicians out there and other groups of people in industry who would consider doing something like an MBA.
Yeah, I talked to several fellow neurosurgeons and neurologists who either have done one or doing one, and I think the first thing about the program is it's 2 years where you have time to think, along with some really smart people from other disciplines, from business, from consulting, from banking, also from computer science, engineering. And where else do you get to take that 2 years to try something? And for me, my biggest takeaway was, if you can in your career give yourself a chance to and space to do some innovative things, take it, no matter where it is, no matter what the program is. I think an MBA in particular is helpful because it's designed around, teaching you some of the disciplines of business, but particularly at Stanford, it's not just the disciplines of business, it's things like, storytelling, communication, management. You're not just learning about human resources and like the ins and outs of how, I don't know, Nike set it up, or Nike, as you say in the UK, in the US, set it up. But you're learning actually about the skills of the interpersonal skills of inspiring people, of leading. And I think those kind of programs are excellent at achieving those things, which is why you see so many great companies coming out of programs like Stanford.
Yeah, that's great. I'm going to reiterate what you said about taking time and giving yourself the space. From what I found in the short amount of time I was out here doing the Stanford Biodesign Fellowship and then starting our startup, I think I've realized also that if you're doing full-time clinical practice, your brain just doesn't have the time or the energy to come up with some of these things that you might want to pursue. I've been surprised as well how important the time and space is, really.
Absolutely. The time and space, and being around other people who are on the same or similar journeys to you. Because if you're just trying to deal with the next clinic, the next operating list, then of course that's going to be your focus. But being around other people, like in the biodesign program, who are trying to come up with other clinical needs, going through the need finding journey, it gives you the permission to go and do that as well. And also like-minded people to discuss the issues that you're having as you're trying to work out what actually will move the needle and improve clinical outcomes.
And we've talked about this in other podcasts as well, about how important it is to be around a group of people who kind of give you energy with what you're working on. The same creative people who are looking to push the boundaries and innovate. And also who are going to challenge you a little bit, because I'm sure when you were at Stanford, you met people who were incredible and you're like, oh my gosh, how did they do this? I know I did when I was there. And it's always nice to have that mirror kind of turn back at you and to say, all right, well, if they can do it, why can't I do it? And it's very inspiring in a way.
I agree. It gives you the courage to go and try something, for sure.
Totally. Any interesting, what was your favorite class, I guess, in your MBA? What stuck out to you as something that, you'll take with you?
So I was really focused on the entrepreneurship classes, as well as anything that I could go and do in the engineering school. My parents are both engineers. Actually, my father's an engineer, my mother's a computer scientist. And so that was in some ways part of my DNA, but I was always drawn to those cross functional, cross specialty type programs. So biodesign is certainly one of my favorite classes. And then there was another one by a professor called Andy Ratcliffe, who's also a very successful venture capitalist at Benchmark, as well as I think the founder and now chairman of Wealthfront. So he taught a course based on the book Crossing the Chasm. And for me, that was very, very impactful, because it made you realize that, you want to start small. You want to start in a focused manner. Don't try and use a new technology like artificial intelligence, try and solve everything at once. Try and solve a real problem for the stakeholder who matters the most, which is the patient. Right? And once you're doing that, you're going to be able to use that beachhead to expand. And I reckon, if anyone is thinking, any of the clinicians out there thinking, hey, I might start a company, that book, Crossing the Chasm, is one of my favorites, and I thoroughly recommend it.
No, that's a great, definitely needs to be on the reading list. Dr. Tom Fogarty says the same thing. I mean, you mentioned the patient, and he always said that if you keep the patient the center of your innovation process, then, you're going to be successful in one way or another.
Yes.
And I think that's very important to reiterate. One other thing that I'd like to ask, and this is something that I think if you haven't gone through some type of business or management program, it's a part of the innovation process that I think can be left out if you just start hitting the ground innovating, is the market size, how well you evaluate your market to see if there's, if it's a high impact area where you're really going to be able to impact a large number of patients. How important is that? Did you already understand this going in, and what did you learn about how important market is when you're trying to, get a innovation to commercialization?
So I think the answer is different depending on which stage of a business you're at.
Okay.
I think when you're at the stage where we're right now, which is the growth stage, the two things that really matter are how fast you're growing and what is the overall total market that you're addressing. And I think if when you're raising money from venture capitalists, they're the two things they most care about. In the early days, though, you really don't know exactly what the innovation, the product market fit, the total market size is ultimately going to be. Partly because markets change and develop. The Google team, Larry and Sergey, didn't know what search was going to become when they were first starting Google. They just had a better search algorithm, right? Same thing for if you look at some of the more recent successes like Slack and Stripe. Like when they were starting out, people wanted to use what they had, but they didn't know it would become as big as it is today. And I often caution entrepreneurs not to be too McKinsey-like in their assessment of markets, because there's a reason why like some of the smartest people at Stanford Business School were probably the McKinsey consultants, but very few of them went on to actually start a company because they saw all the reasons why things would fail. But we've seen in 2020 just how much the world changes. And if you built a company that was perfectly attuned to the total addressable market size of 2019, well, that company is not likely to succeed now in 2021 and beyond because things have changed. And it leads me to caution when you're in the early stages of being too analytical about how large a market is. I would just make sure that it's big enough, and that your technology is flexible enough that it can grow into something as the world adapts around you.
That's perfect. Yeah, I think that's a really, really great point about how markets are dynamic. They're never static, and especially as this last year has proven, whole new market segments have exploded with telehealth in general. And so I think I will repeat what you said just now, and that is make sure your market is big enough at the beginning. I think that's really probably that's important to have, I think, at the very beginning. So when you're working on something, just make sure that it's high impact. And if it's a true clinical need, kind of like BioDesign says, that you've vetted that clinical need, and there are enough patients out there who need it solved, then I think you're on the right track, and you can kind of just put up a ballpark number of your total market size, and then just work on making it the best it possibly can be.
Yeah. And like you said, send to the patient. And if there's enough patients who struggle with that disease, that condition, then it's likely that you have a potential business there if you can solve that problem for them.
Perfect. And so would you do it again? Let me ask, would you pursue an MBA again? I know, yeah, that's a tough question, but.
Oh, no, absolutely. I thought you guys, would I start a company again? Yes to both. It's always, I would definitely pursue an MBA again. And again, not, people have different perceptions of like the value of what you learn in an MBA, but it's not about what you're being taught. It's about what you learn. It's about the people you're around, the people the friends that you build. It opens up a new space in your mind for what you can do. So I would definitely do it again, and I would encourage others if they have a chance to take it. But that's not just an MBA, right? That could be another graduate program that you take halfway through your career. I think it's a great idea.
Awesome. And so you said you came up with the idea for Viz at Stanford. What was the kind of the genesis of Viz? Why? What's the clinical need, and what was the reason behind it? Was there a specific patient or something that prompted you to want to start this?
Absolutely. So back then, this is in 2015, and I'm in the biodesign course with an endovascular neurosurgeon, Jeremiah Johnson. And the Mr. Clean data came out showing that thrombectomy was effective, and not just effective, it had a very low numbers needed to treat for a devastating disease that I knew well. Like my grandmother had had a large vascular occlusion stroke. And, we all of a sudden we had the therapy to treat a patient that was proven, and not just in one trial, but in numerous trials in 2015. But I realized that actually, if you looked at the statistics, very few patients who had an LVO, a large vascular occlusion, were being treated. It was around the 2%, 3%. And, it wasn't because if a patient showed up to Stanford, it wasn't that they weren't being treated. They usually were. It was the fact that often if you show up to a hospital without an interventional specialist, without a stroke neurologist, it wasn't being picked up, it wasn't being referred. Maybe it was, but the workflow wasn't appropriate. The ambulance would take too long to show up. There were a huge variety of reasons when you went through the biodesign process why these patients were not being treated as often as they should, and B, why in the Stratus registry, which is one of the largest source of data we had at the time, we saw that the median time to treatment was between 3 and 5 hours. Whereas in the best centers, you could get patients, if they showed up to the hub, you could get a patient from door to groin in 30 minutes. And in a spoke, you could get door in, door out times of an hour. So why wasn't that happening consistently? And I just thought back to some experiences I had in practice where I did a TED talk about one young lady who had a subdural hemorrhage and who died despite the operation going well. And in the mortality and morbidity meeting, realizing the reason why she died wasn't anything we did in the operating room. It was the 4 to 5 hours it took and the delays it took to get her there. And you've been through the biodesign program. It really encourages you to stop thinking about what you might do as the clinician and focus on the whole clinical need. Because if it's the transporter that's the problem, if it's the transfer center that's the problem, that's where you need to focus. And so we realized that this new technology, deep learning, which had just come out of the labs of Jeff Hinton in Canada and was really all the rage in Stanford at the time, which was able to pick out patterns in data. So it could tell you the difference between a cat and a dog, for example. We realized that potentially we could use that to pick out patterns in CT scans or in other medical data and use that as a trigger. And at the time, there were a bunch of other AI imaging companies who were really focused on improving things for the radiologist, like improving maybe the measurement of something or the detection of something. But ultimately, the radiologist does a good job of that for the most part. The issue is connecting the dots between the ED, the radiologist, the neurologist, and the interventionalist, with all of the amazing healthcare providers that go in between, the stroke coordinator, the stroke nurse, the ambulance driver, the EMT. And there's many, many people. It's incredibly complex. But what if within a minute of the scan, an algorithm would read that scan and alert the right neurologist or neurointerventionalist, so they could go, yep, these images show a patient who I could potentially treat. Let's transfer them over. All of a sudden, you would turn healthcare from a push model with numerous steps and handovers and 3 to 5 hours of delays to one where decisions could be made within minutes, where you'd have the team that really understands the disease and the time-sensitive nature of the disease driving the workflow. You could potentially shorten time to treatment significantly, and that's ultimately what we have proven out.
So what I'm hearing, that's great. What I'm hearing is it's really a workflow problem.
Yes.
From your end, it was a workflow problem, and maybe the timing was right to use a technology like AI to help solve this problem. And but again, it was probably the workflow was the hard part for you guys. How do you figure out how to connect these dots in a quick way? And then the catalyst would be once the scan is done, then Viz would does it automatically read the CT scan right when the scan is done, and then it starts this whole kind of domino effect afterwards?
Correct. Yeah. So it's reading any of the scans coming off the system. If it's a ischemic stroke, it's going to be a CT angiogram. And if it sees a large vessel occlusion, perfusion mismatch, it is going to send an alert to the relevant stroke team, and that's obviously the vascular neurologist and the neurointerventionalist, as well as the local emergency room physician and radiologist. And immediately they're connected. It's via a mobile app. They click on the alert, they view the images like in a matter of seconds, and they can immediately communicate. So, typically we will see scan to decision times of around 3 to 5 minutes, where you've not just got decisions of, hey, I can treat this patient, but you've got communication between that spoke and the hub, where they're saying, okay, we're going to transfer this patient over to, you name the comprehensive stroke center.
Yeah, that's great. And I had a chance to download the training app that you guys offer and look at the images. And, from a radiologist perspective, the images were great. Very high quality. I was curious, and it's a very intuitive user interface. I was curious how much time you guys put into your image quality and user interface experience.
A lot. I think, we realized early on that an algorithm on its own was not going to be the product. And really, this would only work if the radiologist, the neurointerventionist, the neurologist could roll over in bed and, make a determination if this was a patient they needed to act on or not. And so we kind of, unlike a lot of the other AI companies, we kind of eschewed technological determinism and instead lent into the complexity of how healthcare is delivered. 2 a.m, as well as 2 p.m. at a major downtown center in Miami versus a rural spoke, and realized that actually the user interface was going to be the key. In healthcare, and we learned this in biodesign, right? The only way that you can change healthcare and workflows is if you make it easier for that clinician who's responsible for that patient and wants to do the best for that patient. But you can only change their behavior if it's easier to use your product than the alternatives. And the alternative,
so lowering the activation energy, basically, that it takes, because they have to make so many decisions on a minute by minute basis, that it has to lower that threshold for them.
I love the way you put that. Exactly. Lower the activation energy. Absolutely.
Okay. And so the as you say, the algorithm was not really, that's not the focus. You needed it to be a beautiful, almost like a work of art, which is what it looks like when you log in. It looks, clean, cleaner than most PACS systems, which was very refreshing. So I am curious, how did you realize that AI was the way to go? I mean, I know it was coming out at the time, and the timing did work. I mean, timing is so important for these things.
Yes.
But it also takes a lot to be able to say, first off, did you have any experience with AI? And if you didn't, I know you said your mom was in computer science, but if you did not have any experience, that kind of takes a little courage to dive into something and say, hey, this is kind of the tool I'm going to use to solve this clinical need.
Yeah, so I think we were looking at the system, and we realized that you needed to focus on the workflow and the user experience, but you also needed a trigger. You need to try and replicate having a neuroradiologist in every CT scanner, so that the neuroradiologist could trigger that workflow. Because for every 1,000 scans that Viz processes, there's maybe 20 or so that actually will have a large vestal occlusion. And so there's 890 that it's not 980, sorry, that it's not
a lot
that it's doing anything with. But we realized that the power of deep learning was to automate that process. They wouldn't get, the algorithm doesn't need to and wasn't designed to get to the level of a neuroradiologist. The point is, these things, once you start looking at, CTAs are relatively easy to pick up. But if you don't look at the scans, if you're an emergency room physician, they're hard to pick up, particularly the more distal occlusions. And so we needed something that could make care consistent. And we saw that in our FDA study. We were able, even in some of the best stroke centers around the country where we did the study, we were able to not only reduce the time from scan to alert of the specialist by around an hour, but most importantly, we reduced the variation from well over 120 minutes down to 7 minutes of variation in when this doctor was alerted.
Wow.
To me, that's the major issue that in healthcare that technology can solve. Right? When things align, that patient is treated, with the standard that we want them to be treated. But on average, that's not the case. There's so much variation in healthcare, and AI solves the standard deviation problem.
No, that's a fantastic point. I think importantly, you found, it sounds like it was a convergence of both the timing was right for AI to be used as a tool. The clinical need was there, and that's obviously, I'd say the foundation is the clinical need. But also, it sounds like you guys just latched onto AI and said, we want you to solve this very focused problem, rather than, as you mentioned earlier, solving 10 different things. You're not going to read the whole CT scan and generate a report for the physician, but you are going to be very good at finding a large vessel occlusion. And, you mentioned that before, but how important do you think that is to, especially if you're dealing with something like AI, to focus in on something so that it becomes very good at one particular thing, but also to make sure that clinical need is or that solution leads to an outcome change?
Yeah. I think it's really the focus on the outcome change. So our product wouldn't work without the algorithm alerting the doctors, right? It has a big difference because it's alerting the specialist across a hospital network and waiting for the process to happen as it does without Viz, like to happen in series, just takes too long. So the algorithm is important, but really it's about like how are you going to improve the patient outcome? Well, you can improve the patient outcome if from the moment they have the stroke to when they get the clot removed from their brain, that time is reduced. And you could do that in many ways, right? You could focus on educational campaigns to make sure people call 911 earlier, and that's absolutely essential. You can focus on, better abilities to read the scans, better workflow, so when the patient comes in through the door of the ER, they're immediately taken for both a CT and a CTA. And we do all these things. If you work with Viz, what's interesting, and a lot of our customers will comment, is it's not just the software, it's the team that comes with it. We have a customer success team that essentially is able to share best practices from every center that we work with so that a hospital in Mississippi can benefit from a hospital in New York and what they've done, and vice versa. And that focus on the solution is really, really important. Now, AI is advancing, almost every week, right? You're seeing new techniques, new tools that are coming out from the major technology companies like Google, who we work closely with. And I think it probably is logical that over time, most images, whether they're radiological images or pathological images, most of them will probably be examined at some point by an algorithm, which will do one of three things. It will help with disease detection, disease measurement, or prediction of what might happen to that disease. But I think ultimately, unless they're part of a whole solution focused on that patient outcome, they're not going to make a difference and therefore not be adopted.
Yeah, you have to have the outcome change before there's going to be the impact and be adopted. If you have something that just is better at finding something, as you mentioned earlier, well, a radiologist is going to do that at some point. Maybe you saved 12 seconds, but that doesn't move the needle in terms of outcomes.
Exactly.
So backing up just a touch, when you mentioned a second ago you're working with Google. How are you guys working with Google?
Well, so they're investors in Viz, right? They did our Series A along with Kleiner Perkins. We have a few different bits and pieces of technology that we're collaborating on with them.
Great.
Probably go into that.
Yeah. R&D, I understand. So you came up with the idea, you came up with the solution, the clinical need was strong. What did you do early on before your Series A? I mean, did you have to raise seed funding, pre-seed funding? How did you prototype feasibility? I think this kind of gets to the core of what we mentioned earlier about just getting started and just moving the ball down the field a little bit. So I am curious, because that's that moment where it's easy to say, it's not worth it. This is a mountain of work we've got to climb.
Right. And it is a mountain. It's a mountain where every time you get to a peak, there's another peak that you discover ahead of you. And that's the joy and the curse of entrepreneurship, I think. So back then, we were focused on learning, so talking to the market, talking to a lot of clinicians. We were building the technology, the mobile viewer, we have a HIPAA compliant messaging service, which now is comparable, right, to WhatsApp, but back then was relatively basic. We were getting guidance from some of the top stroke clinicians around the country, the people who were the PIs of those trials, because we wanted to try and codify what they did in centers like Grady, Erlanger in the south,
Chattanooga.
So those places where in the stroke belt they're treating more strokes than anyone else, and so they've had to get really, really good at doing it. And so we wanted to try and codify that workflow. So to get started, you've got the AI component, which is getting a hold of a data set through research collaborations, annotating the data set, building the models, iterating on the models, talking to the FDA to try and understand and negotiate on what the clinical trial will be, and really just seeking advice from the market and getting product market fit, because you can't ever develop something that's going to work in a lab, right? In a
vacuum.
A vacuum, you have to be out there and understanding what the real world's like, particularly the real world of healthcare. And so we were just doing a lot of that.
And were you building a team at the time as well, or was it just the kind of the core group and you were trying to develop that early prototyping, early feasibility data, so to speak?
Yeah, well, we were lucky, again, being associated with Stanford, we were able to bring in some super talent from the engineering school. And my co-founder, David Golan, was a postdoc there. And he's got to bring in some of his colleagues. I was able to bring in some superstars from the business school, and a small team of 4 or 5 people were just out there learning. We were part of an incubator that had other like-minded companies doing similar things. Actually, all of the companies were not in healthcare. They were all sort of broad technology companies, but we were going through that journey together.
Which incubator, if you don't mind?
It was the Pear incubator.
Okay. So were you going off of the funding that Eric Schmidt had provided? Was that kind of your seed capital at that point, or did he come in at the Series A?
He provided the seed capital through. He's got a fund called Innovation Endeavors, and they did our seed round.
Okay, great. So your funding has gone up a little bit since then. You recently raised $71 million. That was a Series C, correct?
Yes, that's correct.
That's a fantastic number for a lot of people. So tell me, what are you looking to achieve with this $71 million? I assume this is your growth phase. You're looking to really grow with this.
Absolutely. So we've been successful in getting our ischemic stroke product into many hospitals. It's in it's approaching 700 hospitals now. I think around 680 at the last count. And but what we found is that the combination of mobile image viewing with HIPAA compliant secure communication, the on-call schedule, and then algorithms that trigger workflows, so that if the CTA shows a large vascular occlusion, then this workflow should happen. That's very powerful for multiple disease states. And we've had a lot of other specialists, particularly interventional radiology, interventional cardiology, vascular surgery, peripheral vascular, and endovascular surgeons. They've started using Viz more broadly than stroke for their own workflow needs. And so in PE, it's being used to view the CT, PE, the RV-LV ratio, and make decisions on what to do next with the patient. It's being used to arrange transfer from spoke and hub. And what we've essentially built is this new form of software in healthcare, an intelligent care coordination platform, which in contrast to like the EHRs out there, which really you can think of as the system of record, they're really the system of action. They're lightweight, mobile-based tools for the most part that allow things to happen faster and more efficiently, but most importantly, more consistently. Mm-hmm. And we see, great like clinical outcomes in stroke, but we also see great financial outcomes. We see reduced leakage because more patients are followed up sooner. Mm-hmm. We see better satisfaction from the clinical team because it's easier to use and they're collaborative. So it feels like kind of this one team, one dream type mindset. Mm-hmm. And where that sort of that pull from the market has really inspired us to expand pretty broadly. So what you'll see from us in 2021, 2022 is a big expansion into other disease states that can also benefit from this intelligent care coordination platform.
That's fantastic. So you're starting the expansion phase. You mentioned, just kind of wrapping up a little bit here, for my takeaways here are your clinical need was strong because you could change outcomes. I think that's probably the number one takeaway I would have from the beginning. If you're going to work on a project like this, is you must affect outcomes, and it must be clear that you are affecting outcomes. You also seem to focus in on kind of a specific area, which was important. But now, once you've mastered that and shown and kind of worked out probably the kinks that I'm sure come with the system over a couple of years, optimizing and iterating, you've kind of leaned the system out. You've made it a very lean, efficient workflow, intelligent workflow system. Now you're ready to build on that momentum and spread out into other practice areas. Does that sound reasonable as a summary?
Absolutely. And I think we want to work with a lot of your listeners because we need to understand where this technology can really impact patient care. Mm-hmm. And we work with a lot of interventional radiologists. Keith Sterling, Richard Saxon, Dan, I think he was part of this podcast. Will Patel. A lot of these people are helping us say, hey, take this technology and put it here because these other patients can benefit. And that's really what our next journey is about.
That's awesome. So, Chris Mansi, thank you so much for coming on and sharing your story, your path, and now your passion. Let me ask one more question before we go, though. Do you think you will go back to clinical practice at any point?
I wish. I always said I wish I could do both. I've been out since 2014, so I don't think that's going to happen, unfortunately. But who knows?
Again, thank you so much for coming on. That was a great overview, and what an excellent story. So thank you for sharing it with us.
Bryan, thank you for having me. Really appreciate it.